After discussing syntax, semantics of logic in general, we'll talk about a specific kind of logic, which is propositional logic, a simple yet powerful system that allows agent to reason about facts that are either true or false. We'll start with its syntax, move on how meaning or semantics work, and then briefly see how entailment and inference are performed using the same familiar Wumpus word problem. Syntax of propositional logic depends on the atomic sentences, sometimes also called literals, like single proposition symbols like P, Q, W1, 3. Each stands for a fact, and that can be true or false. Assigning true or false to each propositional symbol basically is its semantics. So we can have simple sentences like W13, which might mean the Wumpus is in cell 13. We can have P21, which might mean there is a pit in 21. So in general, at the most basic level, we have atomic sentences, single propositional symbols, and then we can combine those single propositional symbols or atomic sentences to build complex sentences using various logical connectives that combine or modify statements or sentences. So we have 5 logical connectives, which are not, and, or, implies, if and only if, sometimes also called biconditional. So this table shows some examples of not, like not W13 means the Wumpus is not in 13. It's called negation. Then comes the and or conjunction, like W13 and P31. Means Wumpus is in 13 and the pit in 31. Disjunction or, like W13 and P31 or W22. So Wumpus is in 13 and pit is in 31. With this entire construct, we have a or, Wumpus is in W22. Implies shows the implication, like if the left side is true, then the right side is true. Like if Wumpus is in 13 and pit is in 31, then Wumpus is not in 22. The last one is biconditional or if and only if, which is true if the left side is true. So that means if the left side is true, right side is true. If the left side is false, right side is false. Right side is false. Okay. So now let's see this with respect to a truth table as well. Before that, we will just explain what we have discussed using of the propositional logic using a grammar. It's called a Backus-Naur form of grammar, which kind of combines sentences, atomic sentences into complex sentences. Atomic sentences are like the literals and the true-false values. So true itself is an atomic sentence, false itself is an atomic sentence, and true has the value true always, false as the value false always. Complex sentences are sentences combined with respect to different operators, where the operators are like negation of a sentence, the unary operator. Others are all binary operators, sentence and sentence, sentence or sentence, sentence implies sentence, and sentence biconditional sentence. So operator precedences are not, and, or, implies, and all this. Okay, so this is the important thing. We need to remember that operator precedence is a very important thing. Okay, so that means not A and B are not the same as not outside and then within the parenthesis A and B. Okay. So like, let's see if I can write it here. So not A and B is different than not A and B. Okay, so negation operator has the highest preference. So you can express it like, let's say, -2 plus 4 is equal to 2, not minus 6. Okay, it will be minus 6 if it is like this. Okay, if it is like this, then it's minus 6. So negation has a higher order, higher preference or precedence. Okay, remember that. So let's go to the next slide, which kind of discusses more about the propositional logic semantics with respect to those operators, and gives the truth table. Okay, so the same and negation, addition, and or conjunction or disjunction implies that, or implies that is as it is, and biconditional, so, or if and only if. So you can see that for two variables p and q, there are 4 possibilities, right? Both can be false, both can be true, or they can be false or true. The other one will be the opposite. Okay, so negation p will be opposite of whatever the p's value. If p is false, this is true. If p is true, this is false. P and q is, in which case both are true, then this will be true, otherwise it will be false. P or q is when both are false, then only it is false, otherwise it will be true, as long as one of them is true. P implies q is that, so if p is true and q is false, then only it is false, otherwise it is true. Remember that. So implies that is a little bit weird. Is it's basically it's saying if 5 is an odd number, then Thomas is of 20 years old. But if 5 is an odd number, if it's true, then only the other part will be true. Okay, so if p is true, it will imply that q is true. If not, then it's then we don't really care whatever the value of the construct is. Okay, so this is important to understand. So let's see if there is an example. And so basically p implies q means, p implies q, this one means that if p is true, then I'm claiming that q is true. Okay, otherwise I'm not making any claim. Something like, again, that example, if 5 is odd, implies Tokyo is the capital of Japan. That's true, right? Because Tokyo is the capital of Japan. 5 is odd, that's why the right side is also correct. P implies q. Okay, if p, then q. And the biconditional says that p biconditional q is true whenever both p implies q and q implies p are true. So the biconditional can be represented as 2 parts. One is p implies q, and the other is q implies p. So we can break it in 2 parts. Okay, so that's why both p implies q and q implies p must be true for biconditional to be true. So in English it can be written as p if and only if q. So that's the end of the propositional logic grammar.